This lesson is about solving systems of inequalities by graphing. Here's an inequality. Here's another inequality. When you have two or more equations or inequalities, we call that a system. In this case, we'll be graphing this system of inequalities. One thing that would really help you on this video is to have watched a previous video where we graph a single inequality. That video is called Linear Equalities in Two Variables. And I recommend that video before proceeding in this one. So here we go. Back to our system of inequalities. What does it mean to graph a system of inequalities? Well, to help you understand what it means, the first thing I'm going to do is pick a random point, a random x and y value. Question: would this system of inequalities be true when x is 5 and y is 2? Well, let's find out. Let's take the two inequalities in our system, substitute 5, 2 in. Doing the algebra on the first one leads to a false statement. 8 isn't less than or equal to 4. However, plugging 5, 2 into the second inequality in the system leads to a true statement. This raises the question, is this system of inequalities true at the point 5, 2? And it turns out we don't consider it true because we're not looking for points that make one of the inequalities true. We're looking specifically for points that make both of them true. It turns out the point 3, 4 makes both inequalities in this system true. Watch as I show you why. Taking the two inequalities, substituting 3, 4 into the first one, doing the arithmetic, we get a statement here that's definitely true. 2 is less than or equal to 4. Additionally, plugging that same point, 3, 4, into the second inequality also leads to a true statement. So what we've shown here is that the point 3, 4 makes both of them true, and therefore we consider 3, 4 as a solution to the overall system of two inequalities that we have. But of course, solving these by guess and check, as I've done here, won't necessarily give us all the answers. 3, 4 isn't the only point that makes both of these inequalities true. And since our goal is to find all the points that make both of the inequalities true, let me show you a more systematic way of doing that. So the first thing that I would do is graph the first inequality as if it were its own individual math problem. You'll recall from previous videos that to graph an inequality, we change it to an equation. Notice the symbol change. And by graphing that equation, and to do that there are many techniques that you know, but by graphing that equation, what we've found is the line that divides all the trues from all the falses. And so, in order to decide which side of the line is true and which side of the line is false, we will do what we always do and pick a random point. I love the origin because the arithmetic is so simple. So picking 0, 0 as my test point and plugging that in leads me to a statement that's clearly true. 0 is less than or equal to 4. So the origin is a true point. But what that means is that all the true points are on that side of the line, and therefore this yellow shading represents all the solutions to our first inequality. Now let's examine our second inequality, and temporarily we'll treat that as a separate, unrelated math problem. To graph that inequality, we change it to the corresponding equation, use our graphing techniques to find the line, and let's remember that line is the dividing line between the true and the false regions for this inequality. So I'm going to pick a random point. I normally love picking the origin, but just to show that you don't have to always do that, I'm going to pick a different point. And let's test the point 1, 1. By plugging in 1, 1 to this inequality, we get a statement that's clearly false. 2 is not greater than 3. So that means that the point 1, 1 is a false point. But that means that all the true points must be on the other side of this line. And therefore, the pink shading represents all the true points for our second inequality. One last consideration. Notice the strict inequality that we have here. Because we have a strict inequality, you'll recall from a previous video, that means that all of the points actually on that line are not true points for this inequality, and therefore we represent it as a dotted line. But up until this point, we've essentially treated each of these inequalities as if they were separate and unrelated math problems. But they're not. The entire system is one problem. And recall, we're looking for points that make both inequalities in our system true. So here's the logic. If this yellow region represents all the points for which this is true, and this pink region represents all the points for which this is true, and we're looking for all points that make both of them true, then it seems logical that the overlapping region, this blue region here, would be all points that make both inequalities in our system true. And therefore, this is the final solution to this problem. Ending note, these lines protruding out past the shading, in most courses, you leave them there, and most professors are okay with that. Me personally, I think they're a distraction to the solution, so I erase them, and I like to leave my solutions in this format. But that's not a necessary step. You can certainly leave those there. And that concludes the lesson.